Welcome to Lecture 10. Today we shift our focus to a fundamental programming paradigm that organizes code and data in a powerful modular way, object-oriented programming, or OOP. In Python, everything is an object. Understanding what that means and how to create your own objects is key to writing clear, reusable, and maintainable programs. We will explore the core concepts of classes, instances, methods, and inheritance, moving from the objects you have used unknowingly to the objects you will design intentionally. In the object-oriented view, a program is not a single monolithic script. Instead, it is a collection of cooperating objects. Think of each object as a small, self-contained island within the larger program. These objects interact with one another, making use of each other's capabilities to accomplish complex tasks. A program is effectively a community of objects working together. This approach contrasts with procedural programming, where the focus is on functions and the sequence of operations. Here, the focus is on the agents, the objects, and the messages they send to each other. An object is a bundle of self-contained code and data. It encapsulates related state and behavior into a single, manageable unit. A primary benefit of this approach is the principle of divide and conquer. By breaking a large problem into smaller, understandable parts, each represented by an object, we can manage complexity. Objects have well-defined boundaries which allow us, the programmers, to ignore unnecessary internal details when using them. You have been using objects all along. Every string, integer, list, and dictionary in Python is an object. You've been sending them messages like calling methods without necessarily thinking about their object nature. Let us visualize objects. An object takes some input, performs some internal operations using its bundled code and data, and produces some output. This encapsulation is powerful for two reasons. First, objects hide their internal complexity from the rest of the program. When you use a strings.upper method, you don't need to know how it traverses the character array. You just trust it to work. Second, objects also allow their own internal details to be independent of the rest of the program. The string object doesn't care what variable name you give it. It just performs its defined role. This mutual ignorance through defined interfaces is what makes large-scale software design possible. We need precise terminology. A class is a template or blueprint for creating objects. It defines the structure. A method or message is a defined capability or function that belongs to a class. An attribute or field is a piece of data stored within a class. An object or instance is a concrete, individual creation made from a class blueprint. If a class is the cookie cutter, the object is the actual cookie. A class defines the abstract characteristics of a category of things. This includes its attributes, the data it holds and its methods, the behaviors it can perform. One can think of a class as a factory blueprint. For example, a dog class would define traits common to all dogs, such as breed and fur color as attributes, and behaviors like bark and sit as methods. The class itself is not a dog. It is the specification for what a dog is in our program. An instance is a specific concrete object created from a class at runtime. If dog is the class, then Lassie, your specific pet dog in the program, is an instance of that class. The instance holds the actual values for its attributes. This specific dog's breed is collie. Its fur color is sable and white. This collection of values is called the object's state. The terms object and instance are often used interchangeably, though instance emphasizes the relationship to its class. Methods are an object's abilities, the verbs. They are functions defined inside a class that describe what the object can do. If Lassie is an instance of dog, then Lassie bark invokes the bark method. All dogs can bark, but the method is invoked on one particular instance. The terms method and message are closely related. Sending a message to an object often means calling one of its methods. You can inspect the nature of any object in Python. Using the type function, you can see the class from which an object was instantiated. For example, type ABC returns. The dir function lists all the capabilities, the attributes and methods of an object. For a string, dirx shows methods like capitalize, split, and upper. For a list, it shows append, pop, and sort. These are the messages you can send to these objects. We use the reserved word class to define a new type of object. Let's create a simple class called partyAnimal. This class will contain a bit of data, a counter, and a bit of code, a method to increment that counter. The idea is that we can tell a partyAnimal object to run its party method. The dir function is a diagnostic tool. It lists all attributes and methods of an object. For our custom partyAnimal instance, dir_n will include our defined party method and the x attribute, along with many built-in methods with double underscores. These underscored methods are used by Python for internal operations. For common types like strings, dir reveals a comprehensive list of available operations, from lower to split. Objects have a life cycle. They are created, used, and eventually discarded. Python provides special hooks into this life cycle. The constructor is a special method that runs automatically at the moment an object is created. The destructor runs when the object is about to be destroyed. Constructors are used extensively to set up an object's initial state. Destructors are used rarely, typically only for special cleanup tasks like closing network connections, as Python's garbage collector handles most cleanup automatically. The primary purpose of a constructor is to initialize the object's instance variables to appropriate starting values. In Python, the constructor method is always named chore init chore. We can add a destructor named chore del chore. In an example, we modify our partyAnimal class to include these methods. The constructor prints I am constructed, and the destructor prints I am destructed. We see that when we reassign the variable and to the integer 3, the original partyAnimal object is destroyed, triggering the destructor. This demonstrates the automatic lifecycle management. A class is a template. We can create many independent instances from it. Each instance gets its own separate copy of the instance variables. We can pass parameters to the constructor to set up each instance uniquely. For example, we can create a partyAnimal class that takes a name during construction. We then create two instances, s_partyAnimal, Sally, and j_partyAnimal, Jim. Each has its own independent x counter and name. When we call sParty, only Sally's count increments. The two instances are completely separate, demonstrating how objects provide modular isolated state. Inheritance is a cornerstone of object-oriented programming for code reuse. It allows us to create a new class based on an existing class. The new class, called the child or subclass, inherits all the capabilities, the attributes and methods of the parent class. We can then add new attributes and methods or modify existing ones to create a more specialized version. It is a powerful form of write once, reuse many times. We create a new class, football fan, that inherits from partyAnimal. This is done by putting the parent class in parentheses. Class football fan, partyAnimal. The football fan class automatically has the x attribute, the name attribute, the cock_init_tats constructor, and the party method. We then extend it by adding a new points attribute and a new touchdown method. When we create an instance J of football fan, it can do everything a partyAnimal can do, plus its own special behavior. This showcases how inheritance builds upon and specializes existing functionality. Let's recap our key terms. A class is a template. An attribute is a variable inside a class. A method is a function inside a class. An object is a particular instance of a class. A constructor is code that runs when an object is created. Inheritance is the ability to extend a class to make a new, more specialized class. In summary, object-oriented programming offers a structured, powerful approach to managing complexity and promoting code reuse. By grouping related data and functionality into classes, we create coherent modules. By creating multiple independent instances from those classes, we model real-world systems composed of interacting entities. The concepts of encapsulation, inheritance, and polymorphism, which we've begun to explore today, form the foundation of this paradigm. Mastering these ideas will enable you to structure your Python programs with greater clarity and robustness. This concludes our introduction to Python objects. In the next lecture, we will continue to build on these concepts. Thank you.